it's Brock here from Rock Hill Farms, and today I want to give you an update on the progress of insulating this workshop. So when we bought this property, one of the things we really liked about it is that it had this 30 by 50 pole barn. Unfortunately, it wasn't quite ready to use in the capacity we wanted to use it. It just had a rock floor, it had electricity run down just one wall, and there was no insulation. Now, I run a manufacturing business up here, and I've got a crew of about 8 people that work in here every day, so we need it to be climate controlled. So I knew it was going to be a process of getting it the way we wanted it. Before we could even start working in here, I had to get the concrete floor down. That was the first week. And then I spent the next few weeks upgrading the electrical capacity of the building. We upgraded the main and the breaker box in this building, and we ran a lot of new lines and got it all set up the way we wanted in that capacity. All that happened in the spring when we first moved in. And then in the summer, once it started to get hot, I knew I had to get something done about the heat and cooling. So the first thing I did was made some phone calls and got estimates on what it would cost us to have professionals come in and put in a heat and air system and insulate the building. So we were looking at $4,500 for spray foam insulation, and we would have had to take everything out of the building. I didn't like that price, and I really didn't like the fact that we would have to move everything out of here, because a lot of the things that are in here are semi-permanent or take a group of people to move. So I decided right from that I was going to find a way to insulate it myself. The next thing was, where does your heat and your cooling come from? And I was considering a pellet stove, and that would have been a good option, although it would have taken up some valuable floor space that we really can't spare. And that would still leave me with the problem of how to air condition it. So I got HVAC installers to come give me estimates, and I was looking at around $8,500 to put a heat and air system in here. And that's not counting, I still had to get the propane tank and get the propane lines run, and you can see very quickly how this would all be cost prohibitive. At that point, I'm already in the process of a move and getting furniture and appliances in the house, and we had to spread rock to expand the parking area, and there was a lot of expenses going on, so there's just no way I could spend that on the heating and cooling for the building. At that point, I got the opportunity to purchase a heat and air unit off a house that had burnt down for $1,000. And I jumped right on that and went and got it brought over. And so that solved half the problem right there. All I had to do was rent the propane unit outside, so we had electric air conditioning and gas heat. So that just left us with figuring out how to insulate the building. I knew I didn't want to use the spray foam. I also didn't want to use house insulation, so that leaves sheet foam insulation. Let's walk over to one of the walls and kind of look at what we did there. Alright, so what we've been using is this 1.5 inch thick foil-faced foam. It comes in 4x8 sheets. A sheet of it is about $15, I believe, and it has an R value of 6. So what we did is use 2 layers on all the walls. So we had kind of the standard setup, which is 2x running across this direction to connect the 4x4 post, and they had irregular gaps in between them. And so I was trying to decide, do I go in between those or do I go over them? And what I decided was to do both. So a 2x is actually about 1.75 inches or so, and this is 1.5 inches. So I cut the foam to be a tight fit in between the 2x's and kind of pressed them in that way, and then we taped all the joints. On the outside layer, I faced the foil out to reflect the heat back out. Then on the second layer, I sheeted over it fully to reflect the heat back in. On that first layer, I taped the seams. On the second layer, in a lot of places I didn't feel the need to. This is a pretty tight fit, and the seams, in no spot along any of these walls do the seams line up from the sheet before. We did put some adhesive behind them to hold them up a little better. One thing I really like about this insulation is how easy it is to work with. So not only were the gaps in between these boards irregular, sometimes they weren't even perfectly straight, and you'd have a little difference from one side to the other. And so I was able to just mark this, score it, and snap it like you would sheetrock, which made it fitting the sheets tightly together or tightly in between the wood easy to do. So I did 2 layers around all the walls and spent $1,700 on insulation. And I should be getting about an R12. I also feel like it's better than your house insulation as far as wind penetration. So in a span of 2 days, for $1,700, I'd insulated all the walls and felt really good about that part of it. And then I was kind of stuck because I didn't want to insulate all the way to the ceiling, because even if you're well insulated, but you're in a 20-foot high ceiling, when you're heating that, all your heat's going to sit up at the top, and you're going to waste a ton of energy on your heating. So then the natural next idea is, well, let's put in a drop ceiling. But that's also a ton of work. And it's a ton of lumber. Lumber's not cheap right now. So if I was building a drop ceiling around this whole building, I mean, I'd spend more on that probably than on the insulation. And part of the purpose here is to save a little bit of money. So let me show you what I did on the ceilings. Alright, so hopefully this is a view that works to kind of demonstrate what I'm showing. But we have the standard 4-foot trusses running this direction. And with the thickness of the wood, that makes the gap between them a little bit less than 4 feet. So all we did was cut that little difference off, cut the sheet to 47.5 or 47 or whatever it worked out to be on that one. And we fit them in tight, and then we took 4x8 sheets of 3/4 inch plywood that we use all the time for what we manufacture up here, and we just ripped that into strips 2 and 3 inches wide, and we fit this foam up in it tight, taped across it, and then run those little strips of plywood across. And that actually holds them up really well. We're able to tape the seams, so that'll help with air loss. And it was an inexpensive and easy solution for us. Right above my head is where the trunk line is for the heat and air. I ran most of the length of the building in a square ductwork, and then I ran 12 round duct lines off of it in each direction. We spaced them out where there would be one above each workstation, and they were equally spaced throughout the shop. And then, let me see if there's one behind me. Yeah, there's one right back here. So, right there, we've got a exhaust for the heat and air system. And then, let me turn the camera, I'll show you the last one. We're down to one bay left to insulate. You can see this. This is the duct line that we used for all those. When we put the last row of sheeting up, then this will come down right above the door. So we were essentially able to drop the ceiling without buying any lumber. We probably used 2 or 3 sheets of plywood. I didn't really keep track because we already have stacks of it here all the time. And that was all of our lumber cost. So all told, we spent $1,700 on the walls, another $700 on the ceiling. So we spent $2,400 in insulation and $1,000 for the heat and air unit. With the ductwork, I would say we spent about $3,000 to insulate, heat, and cool a 1,500 square foot pole barn with the tall ceiling. I feel like that came out pretty good. Let me show you what the ceiling looks like. So if you can see up there, there was kind of a different type of a foam insulation already up that kind of helps with the moisture or the sweating of the building. Then we also insulated the eaves all the way up. So I was initially quoted around $13,000 for spray foam insulation and a new heat and air unit. And I was able to do the entire thing for about $3,000. And I'm able to easily keep this building whatever temperature we want. We're in January right now, and so we've had plenty of cold weather, and there has yet to be a day where this unit had trouble keeping up. And it's only a 3.5 ton unit, where I was initially told I would need at least a 5 ton unit. And I'm sure that that initial estimate would have been right if we had not dropped the ceiling. But most of this winter we've had the majority of this done, and we've had all the walls done, and now we're down to one strip. So one last day of work and this will all be done. So I appreciate you taking the time to watch this video. In a minute you'll see links to a couple more of our videos come on the screen right here, and I'll see you next time.